Hello, class. It's good to be back with you again today. Sorry for the break last week, but hopefully you were able to use that time for other things that were important. I know that you've got midterms this week, so sorry to throw lessons at you, but at least you don't have a big test with me right now. I still think I'm going to just work at pass fail and pretty sure y'all will pass. So just working towards completion and making sure you get all of your videos done. Um, I'll put it in the email too, but I just realized today that I only had one video from you, and I was expecting 3 videos. So I think you might not have sent 2 of them. Something might have happened. Please let me know what's going on and send those other 2 to me. I only got stage A, B, and C. I didn't get the convection cycle redo, and I didn't get stage D, E, and F. So please go ahead and send those to me. But otherwise, you guys did great with A, B, and C. You're doing well. So I'm just making sure you understand this. That's going to be my goal. It's just that you show me that you understand. So, all right. So back to the Wilson cycle today. Same thing again. Each Wilson cycle, you'll be able to describe what's going on in each stage, give an example of a real location on Earth, and something that you forgot to do in the video for A, B, and C. But please tell me, do igneous rocks form in that stage? If they do, tell me why. If they don't, tell me why they don't form. All right? It's because we're focused on igneous rocks mostly in this class. All right, and I'm going to pull out of this and get us to the correct, how do I get out? Correct slide, because this is the beginning again. So we've done A, B, C, D, E, F. Maybe I'll just go through real quick and click on each of those so we can review what each of those are. So stage A is a stable craton. And Somal, you did a good job explaining what that is. I think it was Somal, or was it Anka? It was Anka. You did a good job of explaining what that is. And that is just a low density continental crust with high density mafic oceanic crust, and that nothing's going on, that this is a passive regime, so nothing's happening tectonically, it's just sitting there. And then, oh, that's great, now I can just do it on the bottom. Wonderful. That was stage A. Stage B, let's do the animation, huh? All right. So in stage B, we've got heat coming up from the mantle, and we've got convection cycles starting to form, and it's going to start to partially melt the crust, and we're going to have some divergence going on here. You did a good job explaining that. And then stage C. Stage C, this is probably the animation for it. No, this is the animation for it. Stage C, that those convection cycles continue, and we get more and more melting, and we get new rock all in here, new mafic oceanic crust being formed. Did a good job with that. So this one definitely has igneous rocks. All right, and stage D. So this is where you guys need to come back and explain to me, right? But this is a passive margin. There's nothing tectonic happening inside of that circle. It's just the edge of the continent. It's very similar to stage A, where nothing is happening. We don't care what's happening over here, just everything in between those areas. Just the edge of a continent, nothing happening. Technically, stage A is surrounded by stage D, strangely enough. And then where's stage E? There's my animation for stage E. So in stage E, that piece of continent is going to continue to get pushed away from the spreading center. And eventually we're going to get another convection cycle coming from the other direction. and there's going to be too much stress on the continental or the oceanic crust, and it will break at some point and start to subduct. When it subducts, it'll be heat and melting and a little volcano that eventually turns into a volcanic island arc. So that's stage E. Igneous rocks here? Yes. Where is this? Where does this happen? The best location example for that would be Japan. Stage F. Where's my stage F? There's my animation for F. All right, and this is the last one that we did together. So we've got subduction happening. We've got convection happening here and here. These are two separate convection cells. And the subduction is going to continue until this gets pushed up. The island arc gets pushed up on top of the continent. And we get a collision. In this stage right in here, we don't have heat added here. In reality, this mantle is quite cool at this point, so it's cooling and sinking, no melting going on, so no igneous rocks being formed in this stage. So that's the last one we did together. I'll get us on to stage G. All right, stage G. All right, so go ahead and find your notes and get those, hopefully got those printed already. And we're gonna go through this. So stage G, it starts off looking very much like stage E, where we've got this old convection cycle that's been happening. But you can see that nothing's been, there's no movement going on here anymore because the continent has run, the island arc has run into and become part of the continent. So now we're going to lose, I'm going to clear this out. Can I clear that? Oh, it won't let me do it again. Interesting. There we go. So this, on this side, this convection cycle, it's going to lose power, and this one's going to take over. We're just going to keep going this way, but we're going to find a new convection cycle that it butts up against. And here's that other old piece of continent right here. There's an old piece of continent there, and I'm going to have to exit out of this a couple times so that I can lose my markings. So old piece of continent right here, and these two opposing convection cycles can't continue to push against each other, so there's going to be stress in the ocean crust again, and it's going to break. This time, instead of the ocean crust subducting underneath ocean crust, it's subducting underneath the continental crust. So let's go back again and see that. The ocean crust subducts underneath the continental crust, and we've got melting there again. And we're going to make not an island arc because this is already a piece of continent, so it's a large piece of land, but we're going to get volcanoes that come up inside of that continent, a line of volcanoes that come up inside of that continent. And this is called Cordilleran mountain building. We're building, this is a line of volcanoes inside of a continent. So what's happening what's happening during stage G? We're getting subduction. So we've got a piece of continental crust here, and I've got oceanic crust here, and it's subducting underneath the continental crust. And as that happens, it's going to start to melt down here. There's my dog. It's going to start to melt here and come up and make volcanoes in the land. So continental crust, oceanic crust, subduction, melting, and creation of volcanoes. What other stage does stage G look like? What stage does this remind you of? Or maybe a better question, what other stage has subduction in it? and then creation of a line of volcanoes, right? About it. A is stable craton, B is rifting, C is creation of ocean crust, D is a stable margin, so there's nothing melting going on there. E is ocean crust subducting under ocean crust, creating a line of volcanoes. Does that sound familiar? Does that sound similar? Yes, it's very similar. So in stage E, we've got ocean crust and ocean crust subducting, one subducting under the other, making a line of volcanoes. A line of volcanoes here. In stage G, we've got ocean crust subducting under continental crust, making a line of volcanoes. So stage E is the answer there. What will happen when the ocean crust subducts into the mantle? What happens to that ocean crust? I've already told you. What's happening down here? It's going to melt. Not 100% of it, actually. Not all of it, but certain minerals in this ocean crust will melt. So we call that partial melting because it's going to, part of the ocean crust is going to melt. And when you melt rock, it's not just called melted rock. At that point, we call it magma. What will happen to that new magma? Well, magma is less dense than the rock around it. Vast majority of the time, normally, magma is less dense, depending on its chemistry, which we'll get to places where magma can be higher density than the rock above it, and it won't go through. And then other interesting things happen. But in this case, this magma is lower density than all of the crust above it, and it will come up, it will rise. It will move up through the continental crust. And when it comes through the continental crust, what will it make? I've already told you the answer to all these questions as we've been talking. It'll make igneous rocks, right? It'll make a line of volcanoes, and all of those are new igneous rock. Examples of stage G. The best example of stage G would be the western side of South America. In South America, we've got the ocean crust subducting, and that's, again, when you have subduction, you're going to have this dark blue line, ocean crust subducting under continental crust. So the continental South America is moving that way, and the Pacific Ocean crust is moving this way. And it's creating, you'll see this line of mountains. This is actually a line of volcanoes with a very specific chemistry, very specific type of volcanoes. We'll learn what kind a little bit later. All right, so this is a good example of Cordilleran mountain building, where ocean crust is subducting under continental crust. If I can get my Google Maps up, or Google Earth. Let that pull up. That's a good place to look. All right, so South America, there you go. That whole dark blue line in there, that's all subduction all along the edge of South America. Dark blue. And then this light color is all volcanoes. Mountains built from volcanoes. All right. Okay. Stage H. We're almost finished. There's only H and I, and then we've got something else, a different regime that doesn't get its own stage. So stage H, over on this side, we have that piece of we've got where the ocean crust is subducting under the continental crust. So this right here is stage G. Sorry, you can't see that. Stage G over here. Over here, we've got stage A, B, C, D. Oh, well, at this point, it's a stage D, right? At this point, because it's nothing happening. But it had been stage E, it had been stage F before. And now we've got a peneplain, which I'll explain what that is in a little bit. All right, let's get this cleared. And start it up. So we've got subduction happening over here. Ocean crust subducting under the continental crust still, and that's going to continue and continue until, I should have made that go a little slower. So what's going to happen is this continental crust is going to move towards this continental crust. It's going to eat all of the ocean crust. It's going to continue to eat that ocean crust all up. Man, go get it. You need something to chew on. Where's your stick? Oh, baby. There you go. It's gonna eat and melt really down all of that ocean crust. Continue to make more volcanoes, and then that piece of continent on the right hand side is going to become part of the continent on the left hand side. They're gonna collide together because these convection currents were pushing them towards one another. All right, so there's stage H. In stage H, you basically end up seeing almost all of the stages. You can't see stage C, but otherwise you can see almost all the rest of the stages. They've been kind of fossilized inside of stage H. So what other stage does stage H look like? All right, again, thinking back through them, stage A is just a stable craton, stable continent with ocean crust attached to it. Stage B, we've got the beginning of rifting. Stage C, we've got new ocean crust being formed. Stage D, we've got a continent with some ocean crust attached and nothing's going on there. Stage E, we've got back out in the ocean, we've got ocean crust and ocean crust. We've got convection cycles coming towards one another, causing stress, break, and subduction. And then when it subducts, it creates an island arc. That's stage E. Stage F, that island arc is going to be sitting here, and here's the continent, and it's going to get pushed up and become part of the continent. All right? Think about that again. An island arc is getting pushed onto the continent. Does that sound anything like what we're doing right now? Yeah, we've got continent and continent running into each other. So in stage H, two pieces of continent becoming one. In stage E, we've got an island arc and a piece of continent becoming one. All right, so what will happen if two pieces of continent are coming towards each other? We're going to get a collision. They're going to become one, right? Question. In stage H, is heat being added inside of that stage? It's kind of a tricky question because the main answer is no. We don't have any heat being added from the mantle. We don't have new melting that way. We do get some major friction from two continents running into each other. We get major friction along this line. A little tiny bit of melting and a little bit of new igneous rocks, but I don't want you to think about that. So in stage H, we don't have major amounts of heat being added, so we don't have new igneous rocks. All right, example of stage H. Best example of stage H, we've got continent running into continent. When this happens, we've got thick continent, thick continental rock. These are low density rocks, and they will not subduct into the mantle because of their low density. It's like try to take a ping pong ball, a low density ping pong ball, and push it under the water. It will come right back up. It can't stay under because it's too low density. The continental rock compared to the mantle is very low density and it cannot go down. So if you've got continent and continent running into each other, what's going to happen is it's just going to push itself up because it can't push itself down. Nothing's going down. It just pushes itself up and it makes the tallest mountains in the world. So where on earth are the tallest mountains in the world? The Himalayas, right. So we're India and Asia are colliding into each other. Right there, India is moving north, Asia is moving south, and we get this line, the Himalayan mountains, the tallest mountains on Earth, because of two massive continents running into each other. And this actually has pushed up all of the land. Let's go ahead and move back over here and look over here again. Oops. Go over to Asia. Whoa! I'm just turning the whole world upside down. There we go. So if you look at India, India is very low and very flat, but most of Asia, I'm going to use this point, all along here, this is called the Tibetan Plateau, and it reaches all the way up to Mongolia. Hello, where's my dot? All the way up here. This is all high land, actually all the way up to here. All of this is high land. And the only reason it's so high, the only reason all of this is so high is because India crashed into Asia. Oops. India crashed into Asia and pushed all of that land up, making mountains and a plateau. Just nuts that India, being so small, could have that much force. But because they're both low density rocks, there's nowhere to go but up. All right, so there's our Himalayas, right? We've got India and Asia running into each other. All right, stage I. Stage I is kind of interesting. In stage I, if you compare these two, stage H and stage I, they're really the exact same thing. The only thing that's happened is that in stage I, all of those mountains have been cut off, completely erased, right? Why? So in stage I, do you see any movement happening, any tectonics, anything extra? No, there's no tectonics happening in stage I. Is there heat being added here? Well, if there was heat added, then there'd be movement, right? So no heat added. If there's no heat added, do we have any igneous rocks being formed in stage I? No. No new igneous rocks being formed in stage I. And then the next question is, why is this so flat? Why is it so flat? And really what's happened is that, man, I wish this would work, is that these mountains were up above sea level, and it rains and it snows, and that rock, those mountains are rock, and they break into smaller and smaller pieces until they become sand, clay, and ions, and by gravity they get washed all the way down to the ocean, leaving a flat continent. But I don't care about that right now. Right now, that's for when we get to sedimentary rocks. That's just to answer your question about that, because you're probably wondering, why is it so flat? All right, so let's look here. This is going to be different examples of the Wilson cycle. Let's look right here. What stage could this be? Well, this is continent with some rifting. You see these little rifts in here, and the fact that it's in Africa should give you some hint that this is stage B, continental rifting. Right here, you can see that the continents continued to move apart, and we're getting some new oceanic crust in here. What stage would that be? C, creation of oceanic crust. I'm going to go quickly. I'm about to run out of time. Stage D, this is stage D, where we've got just oceanic crust over here and continental crust over here. And nothing's happening. So this is a passive margin, passive stage D. We're going to skip stage E and F. So over here we've got ocean crust subducting under continental crust. And again, that's happening on the western part of South America, creating the Andes Mountains. And here we've got continent and continent running into each other, creating these high mountains in the Himalayas. Stage H. So this is stage G, and that was stage H. We skipped a couple stages in there. And one thing that's remaining is hot spots. I've got 5 minutes to get this done. It's not in order because I forgot to turn on recording again. What is a hot spot? A hot spot's just going to be one point of heat that comes up from the mantle and intersects with the Earth's crust and melts rock and then creates a volcano. It's not a line of volcanoes like it would be for a spreading center or for a subduction zone. It's just one little tiny point of heat coming through and making a volcano. So a column of heat rises through the mantle. Where do those form? They can form in the two places. What are the two types of crust that we have on Earth? What are the two types? Continental crust, and we've got oceanic crust. So they can form through ocean crust, they can form through continental crust. Will igneous rocks be formed at a hot spot? If so, why or why not? Well, if we've got heat, we're going to melt part of that asthenosphere and create some melted rock, magma, that's going to create volcanoes and new igneous rocks, yes. So here we've got continent and heat coming up, that hot spot, partial melting at that asthenosphere, lithosphere boundary there, creation of volcanoes and lots of igneous rocks. Here we've got ocean crust, the low density higher density ocean crust, right? Got a hot spot coming up, creating partial melting. This is actually a different chemistry of volcano. Each volcano has its own chemistry, but it's a different volcano. It's going to make an island, one little island. All right, some best examples of these locations. Hawaii. So in Hawaii, what we've got is the Pacific crust is moving along because of plate tectonics, and we've got one spot of heat that's coming through, and it's just in one spot. So it creates a volcano here, and that volcano is rock, so it stays there. But the hot spot is staying in one spot, and the crust is moving. So we'll get another set of volcanoes here and more volcanoes here. As this moves over time, these become old volcanoes and smaller islands, and the bigger islands are always wherever that hot spot is. Another good location, as an example, is the Northwest United States. We've got a park called Yosemite, and that whole park has all these amazing things happening because there's a hot spot underneath the continent that's come up, created a volcano, created many places, ways that the heat is coming out of the earth. It's got hot springs, and it's got this bubbling mud. I should find the video. It's really cool. Very cool things that are happening there. Bailey, don't chew on that. Come on. Whee! Chase that. All right, so example locations. When we're talking about hotspots, we don't care so much about the ones that are happening along plate boundaries. They're going to be hotspots along plate boundaries. The ones that are anomalies, where we really call it a hotspot, happen inside of the plate. So Hawaii is a hotspot happening inside the Pacific plate. There are the Caroline Islands that are doing the same thing. These are some smaller hotspots inside of the Pacific oceanic crust. Yellowstone is happening away from a boundary again, inside the continental crust. If you look at Asia, most of northern Asia at least, right? Wow. most of Asia itself, right? There are no hotspots over here. This whole area is kind of just devoid of hotspots, which is really interesting. But we got a lot of them over here in the ocean, and we've got a lot of them in the Americas and Africa. All right, let's see here. Come on. Is that my last slide? Hello. What's going on? Woo! There we go. This is a really interesting way to look at this. So the oceanic crust is moving. This is Pacific crust. It's moving this direction. And if you look under the ocean, you'll find, actually, let's do this. I'm gonna do that really quickly. You'll find this is so interesting. You see that I can't mark here, unfortunately. Oh, there you go. There's Hawaii. All right. And if you look along here, oops, there's this line. I'll see if I can just make that point move a whole bunch of old volcanoes, extinct volcanoes, and then it goes this direction, right? This is really interesting. So where my pin is right now, that's the oldest volcanoes that were Hawaii. Hawaii used to actually be up near Siberia. Yeah. Or the oldest Hawaiian islands were up by Siberia. And that what happened was the ocean crust kept moving, and that hot spot stayed in one spot and kept poking through that moving ocean crust. At this point, the ocean crust changed direction and started moving. Before it was moving more of in a northerly way. Now it's moving, whoa, more of a northwestern direction. Come on. Come on. All the way. Hi, puppy. Until it is where it presently is. And in reality, let's zoom in here. Do you see this right here? So that's next to the big island. That's the new place where the hot spot is. That's going to be where the new Hawaiian island is. Someday, right now that's all under the water, but someday that volcano will become so big that it will poke through and become part of the Hawaiian Islands. I'm realizing this is not working terribly well. I've got 15 minutes till all of my apps turn off. Let's go, and I just realized you've not been having my voice for any of that, so I'm going to have to back up and do the middle of all of that tomorrow. So there again, this is the hot spot, right? And the hot spot, the Pacific plate's been moving over the hot spot, making new islands. So there's an old island, another old island. These are old volcanoes that made islands, and this is the biggest island right now. And in reality, the hot spot right now is over here, and it's making a new volcano that's not above the ocean yet. All right, and same thing over here in Northwest America. There's this hot spot that's been moving along called the Yellowstone Caldera, and it used to be over here, and it's been, as America has been moving, that hot spot stayed in the same spot and poked and poked and poked through. And now, this is a very, right where I drew that box, is a very interesting location. If you visit there, if you visit Yellowstone, which I need to visit Yellowstone, it's a very cool place apparently, you'll see all sorts of interesting volcanic activity. Not because of subduction. Most volcanoes on Earth are because of subduction. But here, these volcanoes are happening because of just one place where one little plume, one pointy place of heat is coming away from the mantle and making a volcano. All right. So I need you to be able to do exactly what you've already done for A, B, and C. I need to see D, E, and F. I've not seen y'all do that yet, so please do that for me. And then explain G, H, and I in the same way. And I'll make up another question about the hot spots. And then I'm going to start the next lecture because this was about 45 minutes, possibly or less. All right, that's all I've got for you.